Hi students, we're going to start by the derivatives. You took the limits, now derivatives. First of all, I'm going to define what do we mean by derivative. Derivative, it means it's the variation of a function. When the function is going up, it means increasing. As you can see here, the function here is going up till all values less than a. If you're moving on this curve, you're going up. We say that the function is increasing. The notion for increasing, we say that derivative bigger than zero. Derivative means variation. Then here it's decreasing from a till b. If you move from a till b, you're going down. So it's decreasing. Here we have at point a maximum point, then decreasing. Here we have a minimum point, then it's increasing. So derivative is positive, then decreasing. So we mean that the derivative here is negative. So in other words, a frame of x is positive from minus infinity till a, where the function is increasing, and from b till c, here you can see that the function is increasing. The derivative is negative from a till b, the curve is moving down, and if x is bigger than c, it's going down. And at maximum here and minimum and the maximum here, we say that it's neither increasing nor decreasing. These are called vertices, so the derivative at these points is zero. So derivative, it means positive when the function is going up. Let me take another picture. For any graph you have, for example, if I want to do it graphically, I'm going to give you a function. Suppose this is the function here. So you're going to say, suppose this is a point, for example, -5, and the elevation here is at -3, and here it's a point 2, and its elevation, for example, suppose here it is 7. So we say here, if x less than -5, any point here f prime of x is negative because it's going down, because here you can see it's going down. And if x is bigger than 2, also it's decreasing. X bigger than 2 or x less than -5. If x is between and -5 till 2, you can see that the curve is going up. So here we say that the derivative is positive. Now at the point -5, we say f prime, always derivative at maximum and negative, maximum or minimum. F prime of -5 is the same as f prime of 2 equal to 0. Why? Because at x is -5, we have a minimum. Here we have a maximum. Knowing that f of -5 is -3, f of -5 is a 3, -3, f of 2 is 7, but the derivative at maximum and minimum points is always equal to 0. So here derivative less than 0, derivative bigger than 0. Going from negative to positive, you have the minimum, so derivative will be 0 at that point. Then derivative here is positive, then negative. Going from positive to negative, we have a maximum point where the derivative is negative. So when the function is increasing on that interval, the derivative is positive. When the function is decreasing, the derivative is negative, and at maximum and minimum point, the derivative is 0. So here, why we have this form? Suppose here you have a function. You can see this picture here. This is the function, and this function, as you can see, it's increasing. If you pick 2 points, A and B, and where the point A has abscissa x of A and f of xa, and the point B x of B, f of xb. If you do the ratio f of xb minus f of xa over xb minus xa, so you can see, because the function is increasing, the ratio is positive. And any time when you have an increasing function, if you take 2 points A and B, so here you can see if this is x of B minus x of A, it's positive. And also because it's increasing, so here y of B is bigger than y of A. So if you do the ratio yb minus ya over xb minus xa, it means it's positive. So this is what's called the slope between the 2 points. You know from before, if you do yb minus ya over xb minus xa, it's nothing else than the slope of the point AB. Now what I'm going to do, I'm going to say suppose xb equal xa, this xa here that you have plus h. So I'm going to add here to h. So I'm going to replace xb by xa plus h. So you're going to get xa plus h minus f of xa, and xb here you're going to replace it by xa plus h minus x of a. These two cancel out. So this is the same thing as we wrote it here, but we wrote here instead of having xa and xb, I took only x of a, and the difference between the point a and b is h. If you do the limit as h tends to 0 of f of xa plus h minus f of xa over h, what will happen? So as this distance here will become near 0, so the point xb will become near point a, so the point b will be near point a, so a and b will be on the same point. So this slope is nothing else than the tangent, okay? And if this tangent is positive, because this is the definition of the slope, so if it's positive, then it means that the function is going up. So this ratio, let the limit as h tends to 0 of f of xa plus h minus f of xa over h is nothing else than the derivative, and the derivative is denoted by f prime. To differentiate between f and f prime, f means the function that you know, this is the function, and derivative, it means when the function is going up. So if this ratio, the limit is positive, this ratio is positive, limit as h tends to 0 of f of xa plus h minus f of xa over h, it means that the function is increasing and the derivative is positive. Let us take an example where a function is decreasing. Here you have point A and point B. If the point is decreasing, you know xb minus xa is positive, but f of xb minus f of xa is negative. So in this case, the slope is negative. You know, the slope is negative. And the same story if this is h, and if xb tends to xa, so this is nothing else than the line will be tangent, and this tangent is nothing else than the derivative. In that case, we can say that here the derivative is negative. Why? Because the tangent at the point A is negative. So what you need to know till now, you need to know that the derivative is nothing else. Derivative, if you have a function, no need to do this proof. If you have a function, the derivative is if you have a point A. The derivative at point A, we denote it by f prime of x of A, is nothing else than the tangent at the point A to the curve. If the slope here, the tangent, the slope of this line is positive, it means the function is going up. If the slope here is negative, it means that the function goes down, and this is the definition of the derivative. So the derivative is nothing else, by definition, using the limit property. If you want to find, for example, f prime of a point 5, and you want to find if you have a curve and you have axis 5, for example, suppose this is axis 5 here. What does it mean f prime of 5? You're finding the slope of the tangent to the curve at x equal to 5. If you have, for example, at x equal minus 1, f prime of minus 1 is nothing else. You take the point here and you do the tangent. Here it must be positive because at point 1 is increasing. Here also at 5 it must be positive. So if you take here, for example, suppose this is 1, you can see that here the curve is decreasing. So if you do f prime of 1, by definition, the answer must be negative because the function is decreasing. So now, so as you can see here, if you do the tangent here, because the function is decreasing, as we said at the beginning, the derivative is negative. Here it's a minimum, so f prime of 0 is 0. Here it's positive. Why? Because the tangent here is positive at the point B. The slope here, the slope is negative. So the derivative is nothing else than the slope, as you can see, is the slope of the tangent to f of x at the point xa belong to the curve. So let us use the formula of the derivative. Till now, you need to know the formula. So we're going to start the formula and we're going to memorize the property. Suppose you have a function which is y equal to a. If you're going to graph y equal to a, it's a horizontal line. So as you can see, it's neither increasing nor decreasing. So the derivative is nil. We're not going up nor down, so we're not moving a variation, so it must be zero. So if you want to prove it, so what do you say? Derivative, either you write it as f prime of x of a, or derivative of function y with respect to a variable x. You can write it like this: dy over dx. It means derivative of y of f or with respect to variable x, or y is nothing else than f df over dx, which is f prime of x of a. This is the formula. Limit as h tends to 0 of f of xa plus h minus f of xa over h. So we know, suppose we have a constant, it means we have a plus 0x. If you want to find f of xa plus h, you must replace this x by x of a plus h. So since we have zeros, it's nothing else than a minus a. F of xa is a, and f of xa plus h is a constant a. So a minus a is 0. 0 over a number is 0. So that's why derivative of any horizontal line is always 0. So if you have f of x equal minus 5, derivative is 0. F of x is 7 over pi. We know that pi is a 3.14. So derivative is 0. So derivative of any constant is 0. Now I want to do the derivative of ax. Ax is a line passing through the origin, so it's the slope. It must be a because we said that the derivative is the slope. So let us prove it. So we do limit as h tends to 0 f of xa plus h minus f of x over h. So we replace x by x plus h. You're going to get a into x plus h minus ax f of x. So here if you expand ax minus ax cancel out, remains ah over h. H and h cancel, so it's a. So derivative of ax is a. What does it mean? So if you have f of x equals 7x, so derivative is 7. Or you can write the derivative of the function f, which is 7x over dx, with respect to variable x. So the derivative is 7. Now here, if you want derivative of minus 3x plus 5, we know that derivative of minus 3x is minus 3, and derivative of a constant we said it is 0. Or we can write it derivative of minus 3x plus 5, so it's derivative of minus 3x over d of x plus derivative of 5 over dx. Derivative of a constant is 0, and derivative of ax is a, so minus 3. Now I have f of x equal to x over 5 minus 10z. You cannot take it as a variable because the variable here is x. So z here is as it's a number. So derivative of 2x over 5, so it's the form ax. So derivative of 2x over 5 is 2 over 5. And 10z, because z is not x, so it is 0. Or you can write it of that sort. Certainly you're going to use this one, but we need to know that for later on in a section called implicit differentiation. Later on we're going to take it after 2 weeks. So here derivative of 2x over 5 over dx plus derivative of minus 10z over dx. Here I don't have x, so like I have a constant as we said, so this is 0 and this is 2 over 5. So till now what we learned? We learned if you have, for example, y equal 7x minus 3, what you need to know. So y prime, the derivative is y prime, which is f prime, is nothing else than 7. So ax is a and minus 3 is 0. Suppose you have axn. This is a property. This is the property. You can check it. If here I'm going to find the derivative of axn. So it's f of x plus h over h minus f of x. So you replace x here by x plus h. You're going to get this one. If you're going to use this property, you can put a in factor outside. This is a and this is b. So if you use this property, you're going to get all of that. I'm not going to go in details because we don't need it. What concerns me is at the end, when h is 0, you're going to get xn minus 1. Here xn minus 2 plus 1. All are xn minus 1. So how many xn minus 1? I have an. What concerns me is the property. The property stay because I cannot write anything without proof. So if you have y equal a x power n. You want to find the variation, the derivative. What do you do? It's very simple. You take the power of x, you multiply it by a, yani an or na, it doesn't matter, it's a product, and you decrease the power by minus 1. I mean here, if you want to find the derivative of 3x5. So what do? You take the 5, you multiply it by the number before, you're going to get 15, and the number will be 5 minus 1, it will be 4. If you have, for example, minus 7x squared, so the derivative here, what will be? You multiply 2 by minus 7, it will be minus 14, and you decrease the power by 1, you're going to get 1. More example, suppose you have y equal 2x5 minus 3x squared plus 2x minus 1. You want to find the derivative, the variation. So what do? You put y prime equal. So you take the power here, 5, you multiply it by 2, you're going to get 10. You decrease the power by 1, you're going to get 4. Minus, you take the 2, you multiply it by 3, 6, you decrease the power by 1, it will be 1. 2x, it's 2, degree 2, because if you take 1, we talked about it at the beginning. So 2 times 1, 1, and 1 minus 1, 0, x power 0 is 1. And derivative of a constant is 0. So let us see this example. Here you multiply 2 by 3, it will be 6x. Derivative of minus 5x is minus 5. Derivative of 3 is 0. Here you want to find the derivative, you multiply 4 by minus 2 minus 8, you decrease the power of 4 by 1, it will be 3. 3x squared, 2 times the 3, 6, and you decrease the power by 1, 6x1. Derivative of minus 7x is minus 7, derivative of the constant is 0. Here you have the x is down, you have a square root, here you have cubic root, etc. Before you start deriving, you must write it of the form axn. So here you take the 3 up, it will be 2x minus 3. Radical x is x power half. Here it's the same 2x cubed. Here it's 2 over 3 inside over outside. 2 over 3, you take it up, it will be minus 2 over 3. Here it will be 1 inside over 5 minus 2x plus 1. Once it's of that form, you can do the derivative. So you take the minus 3 times 2 minus 6, you decrease the power by minus 1. Minus 3 minus 1, it will be minus 4. Here half times minus 5 over 2. Half minus 1 is power minus half. 3 times 2 is 6. You decrease the power by 1x squared. Minus 7 times minus 2 over 3. So it will be 14 over 3. X minus 2 over 3 minus 1. You can check it. It's minus 5 over 3. Here 7 times 1 over 5. 7 over 5. X power 1 over 5 minus 1. The power will be minus 4 over 5. Minus 2x is minus 2. And derivative of 1 is 0. If you have it like this, till now, I have only one formula, which is axn. Ax is a, it's a part of axn. Derivative of the constant is 0. So what do? So first of all, we split. So we do 2x cubed over 3 radical x minus 5x squared over 3 radical x. Radical x, you all know it's x power half, minus 2x over 3x power half, minus 1 over 3x power half. So I take the x's up. I must do it as axn. So 2 over 3, x power 3 minus half, it will be 3 minus half is 2.5, which is 5 over 2. Here 2 minus half, it will be 5 over 3, x 1.5, if you can see it. Here 2 over 3, x power 1 minus half is half, you can see it. Here 1 over 3, x minus half. So once I have it of that form, so I do the derivative. 2 over 3 times 5 over 2, it will be 5 over 3. 5 over 2 minus 1, so it will be 3 over 2. Here minus 5 over 3 times the 3 over 2, it will be minus 5 over 2. You decrease the power by 1, so that it will be 3 over 2 minus 1 is half. Here half times minus 2 is minus 1, you can see it here. Half minus 1 is minus half times minus 1 over 3, 1 over 6, and you put minus 1, so it will be minus 3 over 2. Okay, note, here we can memorize the formula of radical x alone. Radical x is x power half. If you want to do the derivative, it's half x, half minus 1 minus half. Minus half, it will be down radical x. So I want you to memorize derivative of radical x is 1 over 2 radical x. And the same, if you have 1 over x, you can write it as x power minus 1. So derivative will be minus 1, you take it down and you put minus 1 minus 1, it will be minus 2, so minus 1 over x squared. So till now, what do we have as formula? Till now we have, if you have a constant, derivative is, we said 0. If you have ax, derivative is a. Write it on a piece of paper in front of you. If you have y equal with the power a xn, this you need to know it. It will be y prime will be a and x power n minus 1. Particular case, radical x, the derivative will be 1 over 2 radical x. 1 over x, the derivative is minus 1 over x squared. Only radical x must be in the numerator, not in denominator. In the denominator, you take it up as we did here. So now you have this one. So before you start 7x cubed, you can keep this radical x, or if you don't want to memorize it, you can put x power half and do it. But since I have the formula, I need it for later on, so we can keep it. Well, here it's 1 over x, you can keep it 1 over x. This radical x is down, so you must write it as 3x power minus half. x3, you take it up minus 3. This is a constant. Why? Because it will be derivative is 0. So I start. Derivative of 7x cubed is 21x squared minus 3 over 5. What's the derivative of radical x? Derivative is 1 over, you can see it here, 2 radical x, so I wrote it. Minus 7 over 2. Here I have 1 over x. So derivative of 1 over x is minus 1 over x squared. Here it will be, you multiply 3 by minus half, minus 3 over 2, you decrease the power by 1. So minus 3 over 2. Here you take the minus 3. So 15, you decrease the power by 1. So minus 4. Derivative of c is not x, so 0. And derivative of 5 is 0. So if you want, this is optional. You can write it here 3 over minus 10 radical x minus and minus plus 7 over 2x squared. This is optional. You can take the negative to be down if you want, and here you can take it. You can stop here. Now we're going to go to another formula of derivative of a product. This is the proof. If you want to, you can read it by yourself, and the derivative of u over v. So if you do this proof, you're not responsible of. You can say that if you have product u times v, we have proved that if you have u times v, the derivative is u prime v, you derive the first product times v without derivative, plus you derive the second times the first without the derivative. So u times v is u prime v plus v prime u. If you have u over v, it's u prime, you do derivative of numerator times denominator without derivative, minus derivative of denominator times numerator without derivative over denominator square. So let us stop for seconds and read it again. Derivative of u times v is u prime times v plus v prime times u. Derivative of u over v is u prime v minus v prime u over v square. So here one can tell me, okay, why we don't do all the product then do the derivative? It will be easy, okay, but we can do it as it's of the form. Always in derivative, I'm going to start by more complicated problem. Always you're going to ask yourself of which form. This is of the form u times v, and the formula of u times v is u prime v plus v prime u. For this first example, we're going to do it step by step, then we can do it directly. So because this is u and v, so the formula u prime. So I wrote here u as it is, but I add to it here a prime. You can see a prime here times v without a prime. I'm applying the formula plus I put v prime with a prime times u as it is without a prime. So now I go for the prime only. Derivative of 2x cubed, we said 3 times 2 is 6 minus the power by minus 1, so 6x squared. Derivative of minus 3 is x is minus 3. I write 2x minus 8 without derivative because here I don't have derivative. Plus, I need to derive here. Derivative of 2x is 2. Derivative of 8 is 0. So 2 into 2x cubed minus 3x plus 5. Another example. Here I have also, it's of the form u times v. This is u. And this is v. So here it's of the form u times v, and the derivative u prime v plus v prime u. I did the same story. So I put here a prime, as you can see, times v. Then v prime, the second one, times u without derivative. So now you know that the derivative of radical x is 1 over 2 radical x times v. Here I want to do the derivative. So 6x squared, derivative here I don't have x, so 0. This is 0. Derivative of 2x is 2. Derivative of minus 1 is 0 times 3 over 5 radical x. So always if you have a product, you do u prime v plus v prime u. Now this is of the form u over v. Okay, I have before I cannot split in. I gave you an example. Okay, it over 2x, for example, a plus b plus c, you can split it, but from now and on no need to split. You can say, for example, a over 2x plus b over 2x, etc., plus c over 2x, whatever, but and then do the take x up and do it as we did before. But here we don't cannot, because I have 2x minus 3. I cannot split. So that's why it's of the form u over v. Derivative u prime v minus v prime u over v squared. Let us do it step by step. U prime, I put prime as you can see here, times v as it is, minus, here you have the minus, don't forget, derivative of 2x minus 3 times numerator over denominator square. Don't forget to put the square down. So now derivative here 6x squared minus 3 into 2x minus 3. Derivative of 2x minus 3 here is 2 into this one over square. So u times v is u prime v plus v prime u. U over v is u prime v minus v prime u over v square. Now you're going to tell me this is of which form? This is of the form u times v. It's u times v. Now we're going to combine uv and u over v. First of all, this is all. You cannot say this is u over v because I have this whole one. I need to write it in one. Either u over v or u times v. So it's u times v. So u times v is u prime times v, as you can see, plus v prime times u. Now I have a prime, so I ask myself, this is of which form? This is, you can see, it's of the form u over v, and here it's of the form also u over v. What's the derivative of u over v? U prime v minus v prime u over v squared. Everything you have a property. You cannot put your own property. So this is of the form u over v. We're going to do it directly. U over v is u prime. Let us derive the numerator. It's 4x minus 3 times denominator minus, derive the denominator, 5x plus 2 is 5 times the numerator over denominator square times this one without derivative, plus, now it's of the form u over v also. Derivative of 2x minus 7 is 2 times denominator as it is. Now I need to derive the denominator, which is 6x, times the numerator, which is 2x minus 7 over denominator square. Then I write this one. Okay, more complicated. One can tell me why we don't multiply here, expand, we have directly u over v in a simple way. We can do it, but my aim here is to teach you how we can combine both. Now you cannot tell me this is of the form u times v, because it's not u times v. This is of the form u over v. This is u over v. Which one is u? This whole expression. We're going to do it step by step. The derivative is very simple, but you must be careful. So u prime, so I wrote it all, the numerator, it's of the form. Always ask yourself of which form. This is u prime, numerator times v, minus v prime times u. Now I have a prime. Guys, don't do derivative times derivative. This is wrong. This is of the form now u times v. So u times v is u prime v plus v prime u. So derivative of 2x squared minus 3x plus 5 is 4x minus 3 times v as it is, plus I derive 7x minus 2, which is 7, times this one. And here I have a prime times 3x minus 5, certainly. I have now the minus. Now derivative of radical x is 1 over 2 radical x, but don't forget you have the 3. Derivative of 5 is 0 times this whole expression over denominator square. Please take a look at it again and redo it. More example. I hope after number till number 11 you will understand. So this is of which form? This is u over v. This is the whole u, and this is the whole v. So it's of the form u over v, derivative u prime v minus v prime u over v squared. So I wrote u prime as it is, times v, this is whole v, minus, I want to derive denominator, I wrote it as it is with the prime. One can do it directly, but for the first example, I'm going to do it step by step, times numerator over denominator, as you can see, square. Now I have a prime. Derivative here of 15x is 15. Derivative of minus 2x squared, so 2 times 2, you decrease the power by 1, it will be 4x. Derivative of 3 is 0. Here I don't have a prime, so I write it as it is. Now I ask myself always ask yourself anytime you have a prime of which form. This is of the form u times v. We're going to do it directly now. Derivative of radical x is 1 over 2 radical x, but I have the 2 before. Minus 5 is 0 times v as it is, plus I want to derive here, it's 14x minus 2 times 2 radical x minus 5 as it is, and I have this one. Do you have any more a prime here? No, I don't have a prime, so I'm done. No need to expand, you can keep it. Once you don't have a prime, you stop. Now I have derivative of trigonometric functions. You need to memorize these. Also, we prove it using the formula of limit as h tends to 0, but no need to do it again. So directly memorize it. Derivative of sine x is is cosine x. Derivative of cosine is minus sine. Derivative of tangent secant square. Cotangent minus cosecant square. Secant is secant tangent, and cosecant is minus cosecant cotangent. So you need to memorize these. So what do you need to memorize? You need to memorize these, and with the uv derivative, we said is u prime v plus v prime u. You have u over v, and you have the radical x, 1 over 2 radical x. You have 1 over x minus 1 over x squared. You have axn, it's an xn minus 1. So you need to memorize these. Don't forget that ax is a, and derivative of a constant is 0. So these are the formula. You must write it in front of you. You need to memorize it so that you can do the derivative without any mistake. So sine is cosine x. Cosine x is minus sine x. Tangent is secant square. Cotangent minus cosecant square. Secant is secant tangent. Cosecant is minus cosecant cotangent. So now write it on a piece of paper so that we can start. Now I have to find this derivative. Derivative of cosine x, we said it's minus sine x. So it will be 2 sine x here, 2 sine x. Derivative of sine is cosine, so it's minus 3 cosine x. Derivative of secant is secant tangent. I hope that you wrote these and you're checking. Derivative of 5x is 5. We did it. Cosecant is minus cosecant cotangent, and you have minus, it will be plus 2 cosecant cotangent. Derivative of tangent is secant square x. Now I have 2x times sine x. Now I'm going to ask of which form. This is of the form u times v. So derivative will be u prime v plus v prime u. Let us do it directly. Derivative of 2x is 2 times sine x as it is. Derivative of sine x is cosine x times 2x as it is. Here it's of the form u times v. So we're going to do the derivative here. 6x, we don't have a square. 6x, derivative of 7, 0. Here 10x4, d is a constant, 0, times 2 cotangent x minus 7. Now derivative of cotangent is minus cosecant square, and you have 2, it will be minus 2 cosecant square x. Derivative of 7 is 0, times this one, you write it again. Here it's of the form also u times v. Derivative is u prime v plus v prime u, like this formula. So derivative of sine, 3 sine is 3 cosine times secant. Now derivative of secant is secant tangent times what? You have 3 sine, secant tangent. Here we have mistake, times sine x. I'm going to repeat this one because I have a mistake here. Derivative of 3 sine x is 3 cosine x times secant x, plus derivative of secant is secant tangent times 3 sine x. This is of which form? It's of the form u over v. We're going to start u prime, but you can see in u prime, I have u times v. So let me do it step by step. So I'm going to say it's u prime, which is 2x. I did it directly because you can start doing it directly. 2x tangent x prime times v, which is 2 tangent x. I'm not going to write it, which is v, minus v prime. I don't have a problem in v prime. We're going to do it here. This is v prime. We're going to check it times u, which is 2x tangent x. Now this is of which form? This is of the form u times v. So derivative of u times v, u prime v plus v prime u. Derivative of 2x is 2 times tangent x. So we have here 2x times tangent x, so 2 times tangent x, you can see it, plus derivative of tangent is secant square x times 2x, plus secant square x derivative of tangent x times 2x. Now I have u prime, so I'm done with u prime. So I write v, this v, minus derivative denominator. Derivative of tangent is secant square, so 2 secant square. Derivative of cosine, oh, I have a mistake here. Derivative of cosine is minus sine. So derivative of minus 3 cosine x is plus 3 sine x. So instead of cosine here, I have sine x times the numerator, which is 2x tangent x over denominator square. So let me repeat. This is of the form u over v. U over v, I need to have u prime. You can do it directly, but u prime here is of the form u times v. So no need to do these steps anymore. U times v, so it must be, always ask yourself of which form. So u times v is u prime v plus v prime u. Derivative of 2x is 2 times tangent x plus 2x, you can see here the 2x. Derivative of tangent is secant square x times v, u prime v, minus v prime, derivative of tangent is secant square, you can see it here. Derivative of cosine is minus sine, so plus 3 sine x into 2x tangent x, which is the numerator here, over denominator square. Here the same story, of which form it's u over v. Let us do it together. Derivative of numerator is very easy, 3 times denominator as it is, minus. Now you want to derive denominator. Denominator, you ask yourself of which form. It's of the form u times v. So u prime v plus v prime u. Derivative of sine is cosine, so 2 cosine x times tangent x, plus derivative of tangent is secant square x times 2 sine x, times numerator, which is 3x minus 5 over denominator square. Denominator square, you can put all square, or you can, because it's a product, 2 square is 4, sine square x, tangent square x, or you can put parentheses all square. Here, this is of which form? This is of the form u v w. u v w, I have 3 product. Even if you have 4, it's u prime v w plus v prime u w plus w prime uv. And I mean, you do derivative of one of the product times the others, plus the middle times the other, plus the last one times the other. So derivative of 3 cosine x is minus 3 sine x. You copy these two. Now I want to do the derivative of cosecant. Cosecant is cosecant minus cosecant cotangent. So put minus before, and you copy 3 cosine x and the x minus 2. Derivative of x minus 2 is 1, you can see it, and you copy 3 cosine x cosecant x. Now here of which form? It's of the form u over v. So u prime, so derivative of 5x is 5, sine x is cosine x minus 3 cosine x times denominator. Now I'm going to ask myself, what's the form of denominator? Denominator is of the form u times v. So derivative of 3x minus 2 is a 3 times secant x. Derivative of secant is secant tangent times the 3x minus 2. Then don't forget to put the v, because it's u prime v minus v prime u over v square. Here I wrote it each one alone, all together square. One can tell me I can write it as 3x minus 2 all square secant square x. Okay, that's it, please. The derivative is something very simple, but you need to be careful. So I want you to be ready for your Monday assessment.